Okay, I'm Carly Roberts, and I am covering Newton's law of cooling. So in Newton's original testing, where he was performing experiments for this law, he worked in a controlled indoor setting where he can observe how hot objects cooled in air, and then he ensured the ambient temperature stayed steady. The ambient temperature is going to be the outside temperature. Newton used simple tools that were available at the time. In the 1600s, he's concluded thermometers, metal containers, water, whatever liquid he could use. We've grown a lot since then, which I would talk about more at the towards the end of this presentation. His scientific procedure consisted of heating an object or liquid and placing it in a cooler environment where the temperature was then recorded. During this time too, there was no technology. Obviously, we're in the 1600s at this time, so he had to write down everything. The temperatures were hard to control, which created different problems. In this experiment, he began to notice the cooling rate was faster when the object was much hotter than the room and slower when the temperatures were close. From continuous experiments, he formed the law of cooling. So this obviously laws aren't something that you perform a one-time experiment and then, try to make something further from it. So in his original difficulties, without our modern day equipment and technology, it was difficult for Newton to collect accurate data. He struggled to find a way to keep external temperatures at a constant. Most thermometers and containers at that time were highly fragile, which made for a more risky and dangerous work environment. Without our modern day equipment, experiments for him were just difficult. Thermometers weren't very accurate. They had thermometers, they had a low response time. Newton, like I stated before, had to record all data by hand because obviously he didn't have a laptop there where he could just write it out on. There were no digital calculations, graphs, tools, and so analyzing the data that was collected involved hand calculations, and that just increases the risk of human error. Let's see. Isaac Newton's original motivation, or his goals in his experiments, was to be able to understand how objects lose heat due to their surrounding temperatures over time. Let's see. His goal with the laws he created was to be able to explain scientific behaviors using physical laws. His discovery was intentional. It wasn't something that just he wasn't looking for and just happened to come about. He was observing and trying to find a pattern within his experiments. Scientists have benefited in many ways in different areas: physics, chemistry, climate control, just the study of weather in general, trying to predict it. His discovery of the law provided the ability to predict temperature changes in several different aspects. Newton's law of cooling allowed scientists to calculate how quickly objects would change temperature when they are exposed to different surrounding temperatures. It has improved our studies and experiments now. His formulas allow for accurate calculations. Now we can precisely calculate thermodynamics with correct mathematical values given the temperatures. Let's see. In engineering, it helps design cooling and heating systems. As a process technology student, we deal with several different types of heating systems and exchangers, like preheaters and stuff like that. And without that, we wouldn't be where we are now. That's not to say that somebody else might not have went along and made the same discovery, but Newton is credited with the discovery of the law. And then in climate studies, it's used to determine temperature change in any given environment. So now we're on to modern day. I have talked a little bit about it. So today, obviously, the way that we calculate things and use things is way different than that time. Like we have labs that are temperature controlled, we have safety equipment which makes for a safe environment. You know, we don't have thermometers or our beakers breaking and stuff like that. We have proper lab equipment and just generally a lot of advancements since there was in the late 1600s, 1700s, which this took place. Let's see, modern day procedure involves heating an object to record a temperature, placing it in an area with a constant surrounding ambient temperature, use technology to record the data and analyze the data with the advanced technology. Honestly, there's a lot of things that technology does for us. You essentially don't have to always be the brains behind it, because in a lot of cases technology will do it for you. As far as different mathematical things and calculations in general, recording the data and analyzing the data, technology does that for us now. Now, when this law was created, that was not the case. There wasn't an explanation for how many things worked. It was kind of just understood that it happens, you know, until scientists started asking the whys. Modern science has improved Newton's law of cooling by using new advanced technology, such as computer simulation and heat transfer models. We have several advanced models and several different things. You can predict temperatures. Let's see here, we're talking about proper protective equipment again. Now, that's something that is very enforced now. In companies, labs, everything. It's very important to stay safe, and the equipment that you use in general is a lot safer now. You know, safety goggles and stuff have to pass through all kinds of different things to be worn in a lab. Data can be collected by technology alone using sensors which gather the precise measurements, which also reduces the chance of human errors. As a process technology student, our sensors that we use, instrumentation for one, it's automatically changing from different units of measurement. There's no need for the human calculations of that stuff anymore. The sensor, as soon as it's reading it, is automatically calculating that. So that's a different way that we've advanced in technology. The law benefits scientists directly by allowing them to predict how fast objects or liquids gain or lose heat using the equation. It creates temperature-controlled systems that remain stable in shifting environmental conditions. So like in a plant, you know, you don't want your heat of your furnace to change based on the external temperatures or the ambient temperature. Another field that benefits from this is forensics. In order to determine time of death, forensics use that the rate of the loss of heat to determine the death of someone. Also, environmental science, predicting the weather. You know, we can log on any weather app and see weather forecasts for who knows how long away. And so that's something that is very much so improved in modern day timing. Engineering, you know, there's so much technology now, so many advancements now versus the time when Newton was creating these laws. We also have automatic thermostats now. It just automatically detects temperature patterns and automatically adjust heating and cooling without any need for human interference. Let's see. So future expectations. These are just a few ideas that I came up with that I feel like we could use this law as technology is still advancing. We could create more precise models that involve more complex factors such as radiation. We can develop AI-based systems that can predict temperature changes for further periods of time. So further away, then we could improve climate prediction to fight global warming, use improved models to further understand it, more energy solutions such as solar panels, cooling for them to make it the energy more efficient, space exploration and the technology used for it, nanotechnology, the creation of longer lasting electronics by the management of heat in the device and battery. So in conclusion, this law is used in everyday life. Without the basis of this law, we wouldn't have an explanation for how many things work. Temperature is used in so many different things. We talked about forensics. I touched a little bit about on the plants and heat exchangers, climate change, weather conditions, engineering. I mean, it's really used in most different fields. So it is important for us to know how this works. Thank you.